got a plane with the ability to fly 180 kilometers an hour, pointing due east. However, there's a wind coming from the north at 20 kilometers an hour, and we want to know the speed and direction of the plane from somebody standing on the ground. So what's the overall combined effect of the wind and the plane's velocity together? So when we set these up, it is a vector question because we've got directions that matter, but we're taking the velocity of the plane in still air, the 180, as a vector, and we're adding it to the velocity of the wind as a vector, and we're trying to figure out the combined effect, which we call the velocity with respect to the ground. Now on the left-hand side of the equation, once again, we have vector addition. So we have to line this up tip to tail and make a little vector diagram and see if we can find out what the gap is, which we're calling VG. So let's set this up. The plane points due east, so VP, the velocity of the plane, will be due east, and it'll be fairly long. So there's VP, and it's 180 kilometers per hour. Now, the wind is blowing from the north, so it's actually blowing towards the south. So VW is a smaller vector, 20 kilometers an hour, that's pointed down. And we have to draw these tip to tail because we're adding them together, VP plus VW. So at the tip of VP, we're going to start the next vector, which is pointed straight down, and it's quite small, 20 kilometers per hour. And that's VP. So there's my vector diagram. Now my resultant, which we call VG, my answer, always points from the start of your vector diagram towards the finish. Direction matters. So it'll be down at an angle like that. Now I always put 2 arrowheads on my answer, and that's what we're trying to find. What is VG? Well, fortunately, we've got a right triangle here. We can use our normal trigonometric equations along with Pythagorean theorems, and we can solve for VG quite quickly. Let's start with Pythagoras. Now we're just going to solve for the hypotenuse of this triangle. So it's just going to be a squared, which is 180, plus b squared equals c squared, and we're just going to call c VG all squared. And when we do that and take the square root, we get VG is 181 kilometers per hour. So now we've got what's called the magnitude, or the length of that pink vector. And what about the direction? Let's see if we can figure out what this little angle is here. Now I know 20 and I know 180 for sure, so let's stick with those numbers. Let's not use the 181 because we had to calculate it. 20 is opposite to my angle that I'm looking for, and 180 is adjacent. And opposite over adjacent is tangent. So tan theta is opposite over adjacent, but in order to solve for the angle, I've got to take the inverse tangent, tan inverse of 20 over 180. And when I place that into my calculator, as long as I'm in degree mode, I end up getting 6.3 degrees. So my final answer is 181 kilometers an hour at 6.3 degrees, and you can see it's swinging to the south of the east line. So from the east, it's swinging towards the south. So 6.3 degrees south of east.